do is we're doing 6-1. We're getting into our trigonometry. So what I want you to do is in your groups, I want you to decide what do the situations shown below have in common. Go. What do the situations below have in common? Talk to your group. Go. Listen, I like what group back there. Group 5. What did you guys say again?
Different time periods.
Different time periods. So they were saying they have different time periods, and I could see where they were coming from with that. I like Group 7's answer even better. What did you guys say? Louder. Oh, so you're saying movement with some rhythm. The same rhythm? Okay, I like that. So you're saying that they have like rhythm. And then I even like this one the best. Group 4. What do you guys say? So you're saying yes, each thing moves at a frequent rate, or they have something in common. You're absolutely correct. So guys, what you're supposed to see with all of these is that each of these have patterns that repeat. So the sun moves around the earth in a repeated pattern. The heart, what? Yeah, you're right. I didn't take science. I only took math classes in college. Thanks for that correction. So you're telling me that the earth moves around the sun? Yeah. Okay, cool. I learned something new today. Okay. So the heart contracts and expands in a repeated pattern, right? Everybody? Okay, awesome. And then swinging, repeated pattern. And then waves. The way the ocean goes up and down in a repeated pattern. Think of a wave hitting the shore. Okay, good. So we're seeing repeated patterns. So that's what a periodic function looks like, you guys. A periodic function. So here we go. A periodic function is a function that repeats a pattern of y values at regular intervals. So y values at regular intervals. A complete pattern is called a cycle. You have to know that. A complete pattern is called a cycle. And a cycle can start at any point on a graph. So a complete pattern. For example, this is a cycle. See how we start at the top, down, back to the top. You see how we started and came back up and ended where we started. So that's a cycle. Now look right here. We started kind of in the middle, up, down, and we're back to the middle. Do you see how a cycle works? So I could start anywhere. Like I could draw another one. Let's say I wanted to start at the bottom, go back up to the top, and now I'm back to the bottom. That's a cycle. Does everybody understand what a cycle is? A complete pattern. Okay, then a period. A period is the horizontal length / distance on the x-axis of a cycle. So the period, you guys, is the length of one cycle. I'm going to say that again. The period is the length, the x-axis, the length of one cycle. So right here, the length on the x-axis of one cycle. So here's an example of our cycle. The period is the length of that cycle. So we started right here, that was at this x value. We ended right here, which was at this x value. So we could count, that's 1, 2, 3, 4 units. So the period would be 4, the length of a cycle. Scott, do we need to move yet? Any questions? Sweet. Okay, so here we go. We're going to just start practicing. Today's kind of a cool day, kind of easy day, laid back. Pay very close attention though. It says, analyze each periodic function, identify the cycle in 2 different ways, because remember a cycle can start anywhere, and then it says what's the period. So we're going to look at the lengths of our cycles. So we're going to identify 2 different cycles. So we can start anywhere. So looking at this A, I'm going to randomly choose to start up here at top. Alright, and then to make a full cycle, I'd have to go all the way down and all the way back up to the top. Does everybody see how I decided that was one of my cycles? Top, back up to top. So that was x is equal to -3 to, so this is one of our cycles, to x is equal to what? 1. So that was one cycle. Now I'm randomly going to choose another cycle. So I don't know, where do I want to start? I'll start, looks like, right here in the middle I'll start. I'm randomly choosing. That's at x is equal to what? 0. So I'm kind of starting in the middle. So I'm going to go up, back down, and then back to starting at the middle. So x is equal to 0 to x is equal to what? X is equal to, this is 3, so this is 4.
Why wouldn't it be at 2?
it starts at that. You have to go make a complete cycle. So it went up, back down, and back to the starting point. Making a complete cycle. This was the starting point after the dip, right? It's got to be after the dip, the starting point. You get what I'm saying?
You can pick anywhere.
You can pick anywhere. I could have randomly chose right there. I'd have to go back up, down, and then right there where it started. Does that make sense? Okay, so now guys, we just identified 2 different cycles. Now it says, what's the period? Period is the physical length of a cycle. So we know it's between, it started at -3 and ended at 1. So let's count. How many units was that? 1, 2, 3, 4. So our period is 4. Let's check our other one. Your period should always be the same no matter where you start your cycle. So look, in this green cycle, we started at 0. We went 1, 2, 3, 4. So do you see how the period's 4? The length of one cycle. Questions on that? So you're confused. So you should be saying, I don't get it. Your guys' faces tell me. So this is why we don't understand math, because nobody dares ask questions. So I need you all listening. Period is the length of a cycle. You have a red cycle starting up here, but I have no idea what you're confused on, so I can't answer your question. So ask, what's confusing you? The cycle part or the period part?
I was just trying to figure out, like, where your red at.
Oh, yeah, because I covered it up right with the green. So you guys all understand that it went from -3 to 1, so we counted 4 units. Our period's 4 units. Okay.
Wait.
So one more, yeah.
When you name the cycle, you're supposed to just do that sequence, right?
Yeah, because this is a cycle from -3 to 1. Does that make sense? Yeah, that's how you'll like say that's one of the cycles I'm choosing. So your answers might be different than mine.
Yeah.
You could have chosen anything. So let's do one more, you guys. So looking at this one, we can start anywhere. I'm randomly going to say, okay, I'll start right here. So that's at x is equal to 0. Now we started at the top of the point after this slant, right? So we've got to go down, and then after that slant, we started again right there. So that's 2x is equal to 3. There's one of the cycles I randomly chose. I'm going to randomly choose another one. I'll start at the bottom right here, go up and back down to the bottom. So that was at x is equal to -1, 2, 3, 4. X is equal to -4 to x is equal to -1. So then length of my cycle, which is called a period. Period is the length of one cycle. So let's count how many units. 1, 2, 3. Same thing here. You can always check it by checking both. 1, 2, 3. So you see how the period is the length of a cycle. Questions on that? All right. So next thing here, and then I'll let you work for a while. So stay with me. A lot of you are going forward. So it says, identify the periodic function. Is the function periodic? So periodic means the y values happen more than once, the exact same thing. So you're seeing the same pattern happen on your y values. So looking at this one, even though it's bouncing down, the y values don't repeat. Does everybody see how the y values don't repeat? It was high, then got lower, lower, lower. So the y values did not repeat at regular intervals. So this one would not be periodic. Looking at this one, do our y values repeat at regular intervals? Yes. So this one would be periodic. So you have to be able to tell periodic versus not periodic. If your y values repeat in a pattern, then yes. If it's not this pattern, then no. Do you understand what I'm saying? Okay. Now it doesn't always have to be even though, just keep that in mind. If your y values repeat, then you do have periodic functions. Okay, do 1 through 6, go. Read the instructions. Okay, next thing you have to know about a periodic function is an amplitude. Yo!
So what's up?
So, once again, the next thing you have to know about a periodic function is the amplitude. So an amplitude is amount of variation in the function values from the midline. So, from the middle of the function, it wants to know how high. From the middle of the function, how low. It's the distance, like how much distance is covered from the midline. That's the amplitude. So you can do it using the formula, the maximum value minus the minimum value divided by 2. I always just count the distance and divide it by 2. Does that make sense, everybody? So, once again, amplitude is only from here to here. From here to here. The midline to the bottom. The midline to the top. Does that make sense, everybody? The midline is not always going to be on the x-axis. In fact, look at this example. It's halfway through the function. So our lowest is -2 and our highest isn't it working in 2s?
Oh.
Is it? No, it's working in 1s, right?
Yeah.
So this is, if you needed to label it, we could go like this. This is -1, right? 0. This is 1,
Wait, what?
2. I'm labeling the X grid. The Y grid. Right? The Y grid.
The midline just.
And what's this? 3.
Okay.
Okay? So these are working in 1. So you do have to kind of look and see if it's working in 1s or 2s or 4s. You get what I'm saying? It's not always going to work in 1s. Okay, so everybody, from my midline up to here is how much distance? Midline up to the top. Nope. My midline's at 1.
Oh.
Up, yeah, 2. Sorry. Yes, you're right. So my midline is at 1. We're going up 1, 2. So our amplitude is 2. Let's check and make sure that's right. From my midline, we're going down 1, 2. You're right, it's 2. So what I like to do is just do the total distance. That's 1, 2, 3, 4. Oh, sorry. That's 1, 2, 3, 4 divided by 2. Does that make sense? Which is 2. So our amplitude is 2.
Oh.
Yeah, the amplitude is from the midline up, the distance up. Is that so? Height from midline. So the tricky part is that the midline's not always at the x-axis. So the reason how I would do this is I would find the amplitude. Do we need to have a seating chart change? Can you handle sitting by your friends? Because you haven't acted like it today in the least bit of ways. Do I not need to teach you this? Do you already know how to do it? No? So you need the lesson, right? So you shouldn't be talking. Okay. So anyways, the easiest way to draw the midline, because it's always hard to see, I gave this one to you. It's always hard for me at first to see exactly where my midline goes. So the first thing I do is I count the full distance from the minimum to the maximum. So I would have had 1, 2, 3, 4 units, right? So 4 divided by 2 is 2. So our amplitude's 2. To find where the midline is, I start at the maximum and go down 1, 2 units, and then I can draw in my midline. Does that make sense, everybody? Okay, let's do an example. So one example, then I'll let you work. It says, what is the amplitude of the periodic function at the right? What is the equation of the midline? So remember, amplitude is the distance from the midline. So first of all, I just like to look at the total distance in my y values. So it looks like my minimum is at, now look at your y values. We're working in 2s, right? Because this is -4, so this is -2, this is 0, this is 2, and this is 4. So the total distance, it looks like it starts right here at -2, right? And it stops at 4, so -2. So distance, wouldn't this be 2? 4, 6. So my total distance is 6. So the amplitude is going to be 6 divided by 2, which is 3. So my amplitude is 3. So then I say, well, where does my midline go? Well, let's see. Our highest is 4. We know the midline the midline is 3 down from the amplitude. So I'm at 4. I'm going down 1, 2, and 3. So my midline is going to be right here. And that would be at what y value? What is 4 minus 3? 1. So it's at y is equal to 1. So my amplitude is 3. My midline is at y equals 1. Do you see how to do that?
You want us to do midline?
Yeah, it'd be good practice. Okay, one more thing before I let you work. So it says, sketch a graph of the ocean's waves with a given period of 0.9 and the amplitude of 4. So I'm going to draw my own picture here. So your picture might look different than mine, but let me just show you kind of how I go about doing this. So first of all, I make a y and an x. And then we know that periodic functions go up and down and they bounce at the same y interval. So once again, I'm randomly going to start here. And I'm gonna go down, up, down, up. Does everybody see what I did? But I'm not done, I gotta label it. So, and I could do another down, up if I really wanted. Now notice, okay, so couple things to label. You have to label your x-axis. So we know the period is 0.9, which means the length of one cycle is 0.09, sorry. So from here to here is one cycle, right? So on my x-axis, shouldn't this be 0.09? 0 to 0.09, right? Now go ahead and say, okay, well, we're going to have another cycle. I want you to at least draw in 2 cycles. So now another cycle would be from here back up to here, right? So where would that be? 0.09 plus 0.09, right? Yes, so this would be at 0.18. Now not only that, we've got to label the amplitude of 4. So you can either make it even, but we know it's not always going to start even, so however you want. So you know the amplitude is 4. So total distance would be what? Amplitude's from midline, guys. So what would the full distance be? 8. So this would be at what?
4.
You could do whatever you wanted. This is negative on the y-axis. So you're saying you want to make it even and go -4 up to 4? Wouldn't that be a total distance of 8? Giving us an amplitude of 4, right? Does everybody see how to do it? Now I didn't have to do -4 and 4. What if I would have done -2? How high up would I have had to put this? 6, right? To make it 8. Do you see how they're not always going to be exactly split in half? Okay, sweet. So now I want you to finish the worksheet. Finish the worksheet. You have 35 minutes. So every single one of you should be able to finish this.